Welcome everyone. In this section, we are going to go into clustering. Specifically, we're going to talk about what clustering is about. Let me just copy what I've prepared earlier so that we can actually get into it right away. So I've given you a Wikipedia reference, so I'll let that run at the background. So what is clustering? Now, clustering is actually under the unsupervised machine learning categories. So what you have here in essence is that it is the task of grouping a set of subjects in such a way that they belong in a group, hence cluster. Okay, and they have some similarity in one sense or another. Now, the thing about unsupervised learning is that we do not have a target or class as such that we can actually learn from. When we look at iris, we have setosa, vesicolor, on and on it goes. So we have a specific class that goes along, the features that goes along with the class itself. But under unsupervised learning, we get given a whole bunch of data, but there's no label to go with it, so we don't really know what is it that we are trying to actually obtain out of this. And this is where machine learning comes in really powerful, is that it looks to uncover patterns and to inform you as a data scientist what to look for. Basically is trying to uncover some underlying patterns in there. So this is where the space that we're looking at right now. Now, some examples of unsupervised learning, in particular clustering, is computer vision. You have natural language processing, you have the stock markets, and you have the customer or market segmentation. Another one that I did not list here is customer churn or fraud detection. All of these have something in common in that there aren't actually any targets. We don't actually have a specific targets that we're looking at or that's given. We have to uncover those patterns. Stock market is another good example. We were given a whole bunch of text to describe, and we actually need to, from there, find out what the actual sentiment itself, which goes along with natural language processing. So let's just come back a little bit on the cluster analysis. It's given the description extracted from here so that you can actually refer back to it. It's a common technique. It's under data mining as well, and basically it's actually pattern recognition or image analysis to uncover pattern. So there's a whole lot of it for you to actually look into. So I'll leave that for you to actually go through and to understand a little bit more if should you want to actually dig deeper into it. So that's really a quick, brief rundown of it. So the next thing that I want to explain a little bit is that how do you actually cluster them? This is where the different types of clustering techniques actually comes in. Now, to be honest, there are actually a lot more than what I've listed here. I'm just listing 4 here as a start so that you can actually understand what are the various and actually multitude of different ways of clustering. You have connectivity. Okay, so that's really distance-based. An example that we will go through is hierarchical clustering. So this is really based on how close they are to each other. And then you have centroid, which represent each cluster by a single mean vector. The mean is really average. Okay, so we're trying to find the average within that cluster itself in terms of the average that represent that whole cluster. And then you have other types such as distribution based. This is based on statistical distribution. It could be multivariate normal distribution used by the expectation maximization algorithm, or it could be density-based clustering, whereby it defines cluster as connected dense regions in the data space. So meaning it actually is very dense in the certain area, and that actually highlights that that's one way of actually segregating them or clustering them into their own, a class on their own. There are a whole bunch of others. There is the subspace, there is the graph-based, there is the neural model. But in our context, we're really only going to focus on the first 2. If you want to learn more, there are others for you to explore into. But for now, I think just covering those 2 is going to we're going to spend a lot of time talking about just the first 2. So let me go into a little bit more depth on the connectivity-based clustering. There's actually another more commonly known name called hierarchical clustering. It's based on basically the basic idea of an object being more closely related to another object that is close by. Okay, so that's really the basic core idea of it. So I guess the other way to think about it is that, look, if you live in this neighborhood, you're more akin or closer or similar to this neighborhood than another one in another country. Okay, another neighborhood in another country. So in terms of your culture, in terms of your food, in terms of all the actual characteristics. So that's really the basic idea of hierarchical clustering here. Now, at every different distance, it will be represented by dendrogram. We're going to use the actual dendrogram diagram. I'm going to show you that, how to actually plot that. That actually is also why you have the common name of hierarchical clustering. That's where it comes from. Now, the second one, which is quite common and one that is actually popularly used, is centroid-based clustering. And the specific machine learning algorithm that we're going to use is called k-means clustering. Now, as you probably know by now, because we cover another k method, I don't want to mention it here just in case you get confused. K really is actually it's a mathematical notation which represent a number. K could be 1, could be 2, could be 3. So that's really the basic ideas of K. Now we're going to go through how to actually make use of k-means algorithm, but there's only one catch that comes with the k-means algorithm, which is that you do need to specify the number of clusters, which some people argue that's a bit ridiculous because I don't know, because this is unsupervised learning, I don't know what it is to begin with. You're asking me to specify the number of clusters, but that's okay. We're going to use a method called elbow method and also another one, but for now, just remember the elbow method. We're going to go into that in future videos within this section and show you how to actually identify the clusters or number of clusters using the elbow method. Now that's pretty much the end of this lesson, a really brief introduction on unsupervised learning method called clustering. With that, we're going to end this lesson. In the next lesson, we're going to install a library that's done by Sebastian Rascal. I'm going to use that to actually make use of that and show you how to actually first of all install it. And then after that, we're going to make use of it to do some visualization, because it really is an extension. It basically is an extension of scikit-learn, but it's not in part of the scikit-learn main library, but it's one that you can actually make use of it quite easily. So with that, I end this lesson. I look forward to seeing you in the next one.